Today we're going to talk about parallel lines, proving that lines are parallel. Up until now we've said if the lines are parallel, um, then corresponding angles are congruent, or if a transversal cuts parallel lines, um, then alternate interior angles are congruent, or same side interior angles are supplementary, something like that. Well, the converse of all those are also true. So, like for instance, if I take this alternate exterior angles theorem, if parallel lines are cut by a transversal, then the alternate exterior angles are congruent. I can also say if alternate exterior angles are congruent, then the transversal cuts parallel lines, okay? Or the second one, if parallel lines are cut by a transversal, the alternate interior angles are congruent. I can say if alternate interior angles are congruent, then the transversal cuts parallel lines. Or same thing, if parallel lines are cut by transversal, the same side interior angles are congruent. I can say are supplementary. Sorry, mistake there. So if I say if same side interior angles are supplementary, then parallel lines are the transversal cuts parallel lines. Okay, or the angle postulate. If corresponding angles are congruent, then the transversal cuts parallel lines. The only one we haven't really covered much is the perpendicular transversal, and that just says, if you think about it, if you've got parallel lines and it's cut by a perpendicular transversal, perpendicular means it makes right angles, so that's a right angle, and by vertical angles, that one also would be a right angle, and then by linear pairs, that would be an angle, and that would be an angle, and by corresponding angles, that would be an angle, and that would be an angle, and that would be an angle, or that would be a right angle. So if parallel lines are cut by a perpendicular transversal, all the angles are equal. They're all 90. Okay? So the same thing is true. If all the angles are 90 degrees, then the transversal it's a perpendicular transversal cutting through parallel lines. Okay? So ordinarily I'd let you guys do this, but let's just run through these really quickly. It says tell which pair. Okay, so if I'm looking at angle 2 and angle 10, that would be here and here, I can prove that L and M are parallel because if 2 is congruent to 10, then by the converse of the alternate interior angle theorem, then L and M are parallel. Okay? Then if I do the next one, 1 and 7, here's 1, here's 7, I can prove that L and N are parallel by the converse of the alternate exterior angle theorem. See how if you kind of ignore the stuff in the middle and just look at these two lines, those are the exterior angles. Okay, 1 and 5, 1 here, 5 here, those are corresponding angles, so I can prove that L is parallel to N by the converse of the corresponding angles postulate. Then angle 8, which is here, and angle 9 equal 180, so I can prove that M is parallel to N by the converse of the same side interior postulate, because angle 8 and angle 9 are supplementary. Okay? And etc. If you have time, you can go ahead and do the last two. Okay? If we're going to do a proof of one of the converses, I would say, okay, if L is parallel to M, which is given, okay, that's these two, L and M here, okay? If those two are parallel, then these two angles are congruent by the corresponding angles postulate. So I can say angle 1 is congruent to angle 2 by the corresponding angles postulate. Okay? Then I'm given that angle 1 is congruent to angle 3. Okay? Actually, looking down here and seeing that transitive property is coming up, I am going to switch to angle 2 is congruent to angle 1. I'm just reversing the order there. So if angle 2 is congruent to angle 1 and angle 1 is congruent to angle 3, then by the transitive property, if A equals B and B equals C, then A equals C. And angle 2 and angle 3 are corresponding angles for if I think of angle M as the transversal and R and P are the parallel lines, okay, then if angle 2 and angle 3 are congruent, then R and P are parallel by the converse of the corresponding angles postulate. Corresponding angles postulate. Okay? So that's how in a proof the converse would work. You would prove that the proof statement would be that the two lines are parallel. Then over here it's always, if the sentence here is parallel, the reason over here is converse of. If you're talking about angles being congruent, then it's just the regular postulate. But if you're talking about parallel lines, you have to use the converse of.